Good morning to everyone. I am P.M.Arthi, Assistant Professor at Qualitech Multitech, Dr. Rangaraju, Dr. Sekuthala Engineering College, Bhavali, in the Department of Artificial Intelligence and Data Science. Today I will be handling the subject recommended system with the subject for 231 AI 26. This course will help us to understand how the personalized searches work made in the platforms like Amazon, Netflix, or Spotify, and the techniques behind them, such as collaborative filtering, content-based filtering, and the hybrid methods. Today we are going to the topic collaborative filtering. Throughout this subject, we will also explore the importance, applications, and the framework for recommender system, along with the modern approaches in AI and machine learning. Collaborative filtering CF is the most prominent approach used in large e-commerce and media platforms. The key idea is simple. If two persons have similar taste in the past, they will likely to have similar taste in future. The method works across many domains, books, news, music, sports, even news articles. That makes it powerful thus that it does not require any knowledge about the items themselves. It only gives a rating of behavior from the user. For example, if Alice and the bird both like the dark light movies and the birds like other type of movies, then the system will prominently recommend the movie to Alice. The most appropriate, prominent approach to the generating recommendations used by large commercial e-commerce sites understood various algorithms and various physics applications in many domains, books, movies, DVDs, etc. Approaches use the systems of the group to the recommended items. Basic assumption and ideas. Users give rating to the catalog items could be implicitly or explicitly. Implicitly means rate is directly, but explicitly means reviewing options. Customers who have similar taste in past will have similar taste in future. In pure probability filtering, the only input is the user item rating matrix. The output can be a numerical prediction of example, predicting Alice will rate a movie 4.3, a top 10 list. A rating list of items in Alice must be likely to enjoy. This method is fixable. It can generate both a prediction and a recommendation list. Input only one matrix for given user item rating. Output types a numerical prediction indication to what degree the current users will like or dislike in content items. The top level list of the recommended items. Next slide is user-based nearest neighbor collaborative filtering. The earlier and the simplest approach in user-based nearest neighbor. The idea is looking at the target user's rating, find out users with a similar rating pattern as a neighbor, use their preference to the predict that the target will like. For example, suppose Alice is not rate the item 5. If her nearest neighbor Bob and Charlie rated his item 5 power possibly, then Alice is also likely to enjoy the item 5. But this rating raises three important questions. How do you how do we measure the similarity between users? How many neighbors should we include? How do we generate the prediction users neighbor rating? Basic techniques given on active users Alice and item I not yet seen by Alice. Find a set of users who like the same item as Alice in the past and how have rated items I. Use example the average of their rating to predict Alice will like item I. Do this all the items Alice has not seen and recommended the best rated. Basic assumption and ideas. The users have similar taste in the past. They will have similar taste in future. User predictions rating stable and then constant every time. Here the example of nearest neighbor filtering. A data set of rating of current users, Alice and some other users is given. Alice, user 1, user 2, user 3, user 4. They are all neighbors. User Alice rate the item 1 as 5, item 2 as 3, item 3 is 4, item 4 is 4, item 5 is not rated in Alice, and then is not yet seen in Alice. Item 5 not yet seen in Alice. User 1 rate the item as item 1 as 3, 1, 2, 3, 3 likewise. User 2 item number 1, 2, 4, 3, 4, 3, 5 like that, like this. User 3, 3, 3, 1, 5, 4 like that. And user 4 rate the items then 1, 5, 5, 2, 1. Neighbors are related rated the item 5 in the good rating process. Always good rating always. That's why the Alice the recommended system recommend the item 5 into Alice. Determine where the Alice will like or dislike item 5 which Alice has not yet rated or since. In the above example, we list the questions to identify the nearest neighbor. How do we measure the similarity? How many neighbors should we consider? And how do we generate a prediction from the neighbors rating? To solve the question to identify the nearest neighbor in the collaborative filtering method. Measuring user similarity. A popular similarity measures in user-based collaborative filtering, personal collaborations. A, B are users, or AB is the rating of user A from product B. B is the set of items rated by the user A and B. Possible similarity values between -1 and 1. The measure similarity is crucial. Two popular methods are used: personal collaborations. Consider the difference in rating scales. It works well in most domains, especially compared to cosine similarities. Next one is cosine similarity. Measure the angle between two users and the rating vectors. Using the formula to identify them, with similarity measures of the collaborative filtering. They identify the use to identify the nearest neighbor. Sine of A, B equal to sigma P we're using the above formula to compare the values with other users. The values between -1 to 1. Here, the sim value is 0.85, 0 user 2, sim value is 0, user 3, sim value is 0.70, user 4, sim value is 0, -0.79. These values, the minimum value is 0 to user 2. The Alice is nearest neighbor to user 2. The improvement from there are possible. Similarity measures significant weighting. If users correlate only two items, their similarity is unretainable. Weight is reduced. Case amplification. Storage similarities are amplified so they are to increase. Neighborhood selection. Either users and the similarity through the recommended system or a filtering number of neighbors. You see the chart to identify the users and the item rating process. User-based collaborative filtering is memory-based. It uses a rating matrix directly, but it does not scale well for real-world system in million of users and items. Model-based approach instead of here the common prediction function. It uses the sim values in a nearest neighbor, calculate whether the neighbor's rating of for the unseen items high or higher or lower than their average. Compare the rating difference, use the similarity with the A as their weight. Add and subtract the neighbors beyond for the active users average and user response prediction. Item-based collaborative filtering instead of filtering similar users to find the similar items. For example, list rate item 1 and rate item 2 highly. If the item 5 is very similar to the item 1 and it and item 2, then we can predict Alice will also like item 5. Amazon used the methods successfully in 2003 by pre-computing pairwise item similarities offline. This solved scalability issues because item similarities are more stable than user similarities. Not all the neighbors' rating might be equal, valuable. Agreement on commonly liked items is not so informative as agreement on items. Possible solutions give more weight to items that have high variance. Value of number of co-rated items use significant weighting by, for example, linearly reducing the weight when the number of co-rated items is low. Case amplification institution give more weight to very similar neighbors where the similarity value is close to 1. Neighborhood selection use similarity threshold for fixed number of neighbors. Memory-based and model-based approach. One common way to calculate similarity between the items is cosine similarity. When predicting, we does not take all neighbors into account. Instead, we limit neighborhood size to say 20 to 50 neighbors. Research on the movie dataset showed this rated gives good accuracy in practice. Users-based collaborative filtering is said to be memory-based. The rating matrix is directly used to find neighbors, make prediction. Does not scale for most real-world scenarios. Large e-commerce sites have 10 of millions of customers and millions of items. Model-based approach based on offline pre-program, pre-processing or model learning phase. At the runtime, only the learned model is used to make prediction. Models are updated, retained periodically. Large variant of technique used. Model building and updating can be computationally expensive. Item-based collaborative filtering is an example for model-based approach. Item-based collaborative filtering. Even processing for item-based filtering. Even if the item-based collaborative filtering scalable is a challenge. Amazon solved this by pre-computing all pairwise item similarities offline. This means at the running time, only a small set of relevant items are considered. Advantage item similarities remains stable over time. Problem memory requirement can be huge. N2 similarities and N items. Solution only compute similarities for item with a co-rating and apply threshold. Basic idea. Use the similarity between the items to make predictions. Example, look for the items that are similar to item 5. Take Alice rating for this item to predict the rating of item 5. If the item 5 is similar to item 1, the Alice definitely see or buy the item 5. Otherwise, item 2 is similar to item 5. It is less possible to get the item. That this idea to predict the item-based collaborative filtering for the recommended system. Cosine similarity measures, explicit rating or direct user feedback like stars, rating, thumbs, and like the scales. Products better result in the item to item filtering. Rating or seen a vector in n-dimensional space. Similarity is calculated based on angle between vectors. Adjust the cosine similarities. Take average users rating into account. Transform a overall rating set of users who have rated both items A and B. For example, job recommended system, they use the continuous -1 to +1 scale with the slider. Users like a graphical input will take it capture prediction more accurately. Making prediction. A common prediction formula to identify the prediction of item-based collaborative filtering. Neighborhood size is typically so likely to predict the size. Not all neighbors are taken into the account for prediction and analyze the movie lens dataset indicate that in most real-world situation, a neighborhood of 20 to 50 neighbors seem reasonable items in the recommended system. Reprocessing for item-based filtering. Item-based filtering does not solve the scalable problem itself. Pre-processing approach by Amazon.com in 2003 calculate all pairwise item similarities in advance. The neighborhood to be used at runtime by typically rather similar because only items are taken into account which the user has created. Item similarities are supposed to be more stable than user similarities. Memory requirement up to n squared pairwise similarities to be memorized in theory. In practice, this is significantly low item with no co-rating future production problems. Minimum threshold for co-rating, limit the neighborhood size, might accept the recommendation accuracy. No, we can't rating, explicit rating or direct user feedback like star rating, thumbs up, and the like scales challenges users offer does not want to rate many items lead to spare the matrices. Example, in the chat recommender, they use a continuous -10 to +10 scale with a slider. Users like the graphical input and it capture the preference or more accuracy. The probability of most predicted grades, most commonly used 1 to 5 or 1 to 7, like the response scales. Research topics, optimal gradualities of scale, indication at 10-point scale is better accepted in moving down, and even more fine-grained scale was closer in the Jack recommended discussed by Gold year 2001, where a continuous scale from -10 to +10 and a graphical input bar were used. No predictions lost from the discrimination. User preference can be captured at the fire user actually like the graphical interaction method. Multidimensional rating, multiple rates for movies such as the rates for actor and the sound. Many problems user not allow willing to rate many items. Number of available ratings could be too small. Spare rating matrices, poor recommendation quality. How to persuade the users to rate more items, more on more on rating, implicit rating. Implicit ratings are infer for users' behavior. Click, purchase, items spent on page, download, etc. Advantage easy to collect, no effect from users. Problem they are noisy. For example, the users may buy a book in someone else. In practice, system offers combine explicit and implicit rating to get best result, typically collected by web shop and application in which the recommended system is embedded. When the customers buy an item, for instance, many recommended systems interpret this behavior as positive rating. Click page views, time spent on some pages, demo downloads. Implicit ratings can be collected constantly and do not require additional effort from the slide of users. Many problems. One cannot be sure whether the user's behavior is correctly interpreted. For example, a user might not like on all the books he and she had bought. The user also might have bought a book from someone else. Implicit rating can be used in addition to explicit ones. The question is correctness of interpretation. Data sparsity problem. The data sparsity is a major problem. Rating the matrices are mostly empty. The cold start problem causes when A new item entered on the system. New user sign up. Solution: ask the user to rate the few initial items. Use content based or demographic data in the beginning. Default voting, more advanced, accurate transparency of neighborhoods. Cold start problem. How the recommended now items what to recommended to new users. Start forward, straightforward approach. Ask users to rate a set of items. Use another method in the initial phase, like collaborative, content-based, etc. Default voting. Assign the default value to item that only one of the two users to be compared to rated alternatives. Use better algorithms. Example, in a nearest neighbor approach, instead of sufficient similarity, neighbors might be too small to make good practices. Assume transitivity of neighborhoods. Assume transitivity of neighborhoods. Example algorithms for star data sets. Redundancy of collaborative filtering. Assume that is very close neighbors n of you who, however, has not created the item target items I get item. Apply collaborative filtering method recursively and predict a rate for items I for the neighborhoods. Use their predicted rates instead of the rating of the more distant direct neighbors. Here, Alice and the user one is more distant neighbors. We use this method to predict the item-based collaborative filtering. Graph method. One solution to sparsity is to use graph-based approach like separating activity. The idea is use directly connecting. Example, the user 1 and the user 2 both like item 2. The item 4, then the user 1 may like the item 3 because item user 2 also like it. Normally, we use the path of length 3, but in sparse data set, large path can be used to find more resolution of recommended system. Explicit the support transitivity of customer tests and thereby adjustment of matrix with additional information. Assume that we are looking the recommendation for user 1 when use the standard collaborative filtering approach. User 2 will be considered the peer of user 1 because they both bought item 2 and item 4. Those item 3 will be recommended to user 1 because of the nearest neighbor user 2 also bought the bought or like did. Based method. In a standard user based or item based collaborative filtering approach, path of length 3 will be considered. Otherwise, item 3 is relevant to user 1 because there exist 3 steps. User 1, item 2, User 2, item 3, determine number. Focus the number of such of link 3 is small and small rating databases. Items media is to also consider larger concepts in their association to compute well with recommendations to the user and the items using top length, for instance. User 1 is connected to item 4 and item 2. User 2 is connected to item 2, item 3, item 4. User 3 is connected to item 1, item 2, and item 3. Likewise, the idea user path of length 3 to record recommended items. Length 3 recommended item 3 user 2 1. Length 5 8 item 1 also recommendable. More model-based approach. This approach is like market basket analysis. If a user bought items A, they are likely to buy item B. The matrix acquisition technique, statistics, single value decomposition, principal component analysis, association rule, mind, compare shopping basket analysis, coordinates model, clustering model, Bayesian networks, analysis, various other machine learning approaches, cost of pre-processing, using not discussed incredible updates possible. Thank you.